My dear engineers, as you can see my introduction in slide number 1. Now it is discussed earlier also. Now I am going to discuss with you the important topic of concrete technology, on which I have uploaded my first lecture last week on the same topic, and you went through that. So I request you to kindly subscribe my channel, like my channel, and share my channel to as many as engineers in your contact, so that they can also get some technical and practical knowledge. Last lecture I discussed with you about the description of concrete, the components of concrete, plain cement concrete, reinforced cement concrete, water cement ratio, concrete admixtures, concrete mix design, methodology of concrete, concrete vibration, and grade of concretes. All these things were, all these subjects were discussed in last lecture, but now we are going to discuss few more points in this lecture, part 2 of concrete technology. Please make sure that you will comment on this, you will like it, you will subscribe the channel, so that the other engineers also can be benefited. Thank you very, very much. As you know, the engineers, that it's mandatory to get the practical and technical knowledge while you are working on any construction project. Even if you have qualified and got the education by diploma, degree, master's degree, or any other qualification, but at the same time it's necessary that you must get the practical and technical knowledge at construction project. For that reason I have tailored these lectures to refresh your memories and all that. So please make sure that you have to get the technical and practical knowledge when you are working at a construction project, and you can be benefited from my lectures, because I will be posting in these lectures about the civil, mechanical, electrical, plumbing, HVAC, and all the topics which we are related to the construction of a building. So please follow the lectures and subscribe the lecture and share the lecture to other engineers, so that they can also be benefited. Thank you very much. Earlier also I have discussed with you about the concrete components, but in this uh, lecture also, once again I would like to discuss these items once again. Main components of concrete are cement, fine aggregates, coarse aggregates, water, and additive or admixtures. Cement is the bonding agent for the concrete and binds the components of the concrete together. Fine aggregates are smaller particles, typically passing through the sleeve of 4.7 millimeters, and this is called as sand. Sand improves the workability and reduces the voids in concrete. Angular particles provide better bonding, but at the same time round particles enhances the workability and gives the rapid working. Coarse aggregates are larger particles retained on 4.7 millimeter sleeve. They can be gravel or crushed stone. They are called as gravel or crushed stone. The qualities of the coarse aggregate are that coarse aggregate vary in size, generally ranging from 4.75 millimeters to 20 millimeters, but normally we are using 18 mm or 18 millimeters aggregates in concrete. Angular aggregates improve interlocking in concrete, while another round aggregates may ease the workability but reduces the concrete strength and durability. So we have to consider all these things, but while choosing the aggregates rightly and equally, it is essential to producing durable and high performance if we select the right aggregates. Thank you. In slide number 4, we will review the table of scope of works, definitions, sizes of particles, materials, shapes, textures, function in concrete, and finally the use of fine and coarse aggregate in concrete. So this table is very important, and please review the same. Thank you. In slide number 5, we will discuss about the concrete vibration. Means that we have to compact the concrete. Dear engineers, in every slide you can notice that the slide text is different from my video recording, because I can speak on the same topic in different ways. I am writing twice, once in slides, and then while speaking I have to write on another computer and to speak to you about those topics in another way. So revibration, as we can say that a proper executed revibration results in improved concrete quality, increased strength and bonding of the concrete, diminishes the chances of shrinkage resulting in hair cracks, reduces in voids, and concrete can be obtained. Importance of vibration of concrete. Vibrating concrete is critical because by removing air pockets and consolidates the aggregate particles together, it increases the compressive strength of concrete. Tightly packed particles will result in stronger, more durable concrete, and concrete which has not been vibrated is full of small air pockets, which results in honeycombing. Thank you. Number 6, we will discuss about the benefits of revibration of concrete. There are some repetitions in my video, because I want to repeat and repeat every time so that you can understand the topic very well. Eliminating air pockets is one of the quality of revibrating. Voids that may form during the initial pouring ensures better compaction and density. Revibration decreases the porosity and the concrete gets better shapes. Revibration gives a smoother surface, reducing the need of extensive reworks, finishing the improvement of the concrete. Revibration minimizes air pockets and can help reducing cracking during the curing. Overall, the improved density and strength leads to a more durable concrete structure that can withstand in worst environmental conditions. So all these qualities are there of revibration of concrete. Slide number 7, we are going to discuss about the consequences of non-vibrating of concrete. Unvibrated concrete can have significant air pockets, leading to weak spots, and potential structure failure may happen, reducing the strength of overall compressive strength and tensile strength of the concrete, which may compromise the quality, which can affect the integrity of the structure. Segregation may happen without vibrating the concrete. The components of the concrete can segregate, which can give the honeycombing or bad shape to the concrete. Poor surface, when we are not vibrating, we will get the rough and uneven surface, and the components of the concrete are not mixed properly. So all these all these effects are there and consequences are there which affect the concrete if we are not vibrating it. Now we'll discuss about the process of manufacturing of concrete. This is slide number 8. There are different procedures of manufacturing concrete. We will discuss few of them. Number one is material batching or measurements by volume or by weight. Number two is mixing the concrete. Number three, how to transport the concrete. Number four is pouring in formworks, which means in chutterings. And finally, we have earlier also discussed about the compression, means that we have to discuss about the vibration of the concrete. This is these small points we will discuss in a bit detail. Engineers, very quickly we will discuss about the points we highlighted in slide number 8. Material batching. The batching concrete in batching plants. In this process, the components of the concrete are either measured by volume or by weight. Mixing by the mechanical mixer machines is done by the volumetric measurements, and one bag of cement is equal to be the one box area. Mixing of the concrete can be mixed by hand or by mechanical mixer or by batching plant, but we have to take care that all the methods to be done in homogeneous way, the consistency of the concrete to remain. Transportation of the concrete should be transferred to the working place as soon as possible before setting time of the cement. Pouring the concrete in formwork. The concrete, when it is ready to pour, must be transported and to be poured in formworks as soon as early and as possible as safe. So all these precautions are to be taken for pouring of the concrete. Slide number 10. We are going to discuss about the curing. Concrete curing is the process of maintaining adequate moisture in concrete within a proper temperature range in order to support the cement hydration at early stages and at early ages. Hydration is the chemical reaction between the cement and water when these are added together. The result in the formation of various chemicals contributes to the setting and hardening of the concrete. So curing is the most crucial item, and we have to do the curing as per the nature of the concrete. In slide number 11, we'll discuss about drying of concrete. Concrete dries as the water inside evaporates through its surface. Concrete dries within 24 to 48 hours and can be able to walk on it. For concrete to dry and reach its full strength takes about 28 days. The curing process is usually completed after 28 days, and however, the concrete will continue to harden for a significant amount of time and takes days and months, even sometimes, as per the environmental conditions of the location. Even if the concrete is cured, excess water still must evaporate from the concrete. While it only takes 28 days to cure the concrete, drying can take months and months. So we have to conclude this topic, and we will go through the topic again in part 3. Thank you very much. Dear engineers, this is slide number 12 and the last slide. The end of part 2 of lecture on concrete technology, part 2. Part 3 on same topic will be uploaded soon. I am thankful to you all to listen to me patiently, because I am a sick person, I am an old person, sometimes I am not speaking fluently, so don't mind it. I will be thankful to you to please subscribe my channel, like my channel, and share my channel to as many as engineers in your contact. The link is there in my slide number 12. Thank you.